Welcome to the Industry 4.0 Club's Fireside Chat. The club purpose is to engage the power of diverse worldwide talent to accelerate the global evolution to Industry 4.0. We accomplish this by hosting and supporting respectful, thoughtful, and interdisciplinary open conversations and creating quality content on wide-ranging Industry 4.0 topics to expand the reach of our community. My name is Mike Ungar, and I'm the CEO of the Industry 4.0 Club. I have over 40 years of leadership and management experience, most of that with Michelin in manufacturing. This afternoon, we have the pleasure of speaking with David Caputo, who's co-founder of Harmoni. We're going to be talking about a topic that I know is near and dear to his heart, and that's rethinking shop floor execution with factory orchestration. Before we get into our conversation, I wanted to share a little bit more about David. So I mentioned he's the co-founder of Harmoni, which is a factory orchestration platform that unifies people, machines, and processes to improve productivity on the shop floor. He's also founder of RVE Partners, a New York-based private equity firm focused on investments in aerospace and defense manufacturing. He serves as chairman of the WHI Global, a supplier of complex assemblies and components to the aerospace sector, and is a director of Key Data Associates, Inc., which is a cybersecurity advisory and services firm. Previously, David was a director in the Global Investment Banking and Leveraged Finance Group at RBC Capital. He holds a Bachelor of Science in Electrical Engineering from the University of Toronto, and we're glad to have you here, David. Thanks for joining us.
Thanks for having me, Mike. I'm excited to talk to you today.
Yeah, so let's just jump right in. And this topic of factory orchestration is an interesting one. So a lot of manufacturers have invested heavily in ERP, MES, automation, I mean, you name it, a lot of digital tools, yet they still struggle with delays, disruptions, and coordination issues on the shop floor. So talk to me a second, or talk to our audience, what's missing in today's manufacturing technology stack, and why do you believe that factory orchestration is emerging as a critical capability?
Yeah, so that's a great question. And you'd think being in 2026 that we would have all of the software tools that we need to run an efficient factory. The problem isn't the tools themselves. There's a wide range of very effective tools out there that each solve their own piece of the puzzle very effectively. But as you mentioned, things don't always run smoothly on the shop floor. Waste still happens, mistakes still happen, and it's very costly for factories. And this is actually why Harmoni exists. So if you rewind back, you mentioned in your intro that I'm involved with the private equity fund. And so that was actually my first startup back in 2013. And over a decade plus, we acquired a number of aerospace and defense manufacturing companies. And it was through that experience and me living firsthand the challenges on the shop floor that Harmoni actually exists. And so to give you a sense, I could take you right back to some, real world stories that I experienced. I will never forget the first time standing on the shop floor of one of my companies. We won't use names in any of these examples, but I remember standing on the shop floor when the first shift arrived and watching 70 people line up at a ADP terminal and one by one punch in for the day. And then right after that, 70 people line up again at the ERP terminal, that was just down the aisle from it, and one by one fill out a form, and eventually get to their machine. And it was crazy. And I was saying it felt like the Flintstones, right? And I remember thinking, how could this be the way things are done? Actually, my first reaction was, I've made a mistake. I mean, how have we acquired these companies, right? And another example would be, we had fancy work instruction software. Again, great tools, a really great tool. And the operator had the work instruction digitally pulled up right at their work center. And this was to make wing ribs for a business jet aircraft platform. And this was at one of my machine shops. And I remember the operator, the part comes out of the machine and the instructions pulled up and they're following the instruction. There's a manual operation. I think we're required drilling or boring a hole on the part, and then realized after the fact that it was these parts have left hand and right hand mirror images down each wing, and it was the left hand instruction pulled up. It was a right hand part, And sure enough, that was now an $18,000 paperweight that we had there, because you can't just fill that hole in with some Bondo and call it a day for aircraft parts, right? So,
Right.
these are examples of how you can have the tools, but when they're not tied in together and there's nothing that's actually controlling the flow of information, you have humans involved in the process. And the more tools you add, the more complex you're actually making that process. So you can have inefficiencies, like I mentioned in the beginning, where you have people lining up at different terminals to use different systems. They're just following
Right.
you give them. We say first you have to do this, then you have to do that, then you're not allowed
Makes sense.
to work on your machine unless you're punched into our ERP system, right?
Yeah.
So they're just following your process. So it's just an example of how systems don't solve the problem. What you need is actual coordination to tie together these systems to eliminate the wasted motion. And in factory orchestration, we call that labor automation. So you want to eliminate all the wasted motion that comes from having to work with all these systems by tying them all together through a single interface. And then you want to prevent mistakes that result in scrapped parts by ensuring that context that you have, because again, when you're the system that is punching these employees in and out of ERP and time charging, you know who they are, you know what they're working on, you know what machine they're on. And so therefore you can pull the correct instruction and the correct program to run and the correct check sheet to run. And so that's the key. And that's why, you could have all these systems and it doesn't just run as smoothly as you would want it to.
Well, so then I think in some ways you've helped us define what factory orchestration is. Because that term, honestly, in getting ready to have our conversation today, I have not heard that term before. Now, not that I know all the terms that are out there in the market, but so this term's gaining a lot of attention, I guess, because of the things you just described. You're right. A lot of manufacturers we find, I've learned, or seen, have installed one tool to solve one problem. I mean, a plant manager will get their reputation with headquarters because they had this big productivity gain by solving one problem and putting one tool out there. And then the next plant manager will do the same thing, but then the company's left with this, menagerie of tools that don't talk to one another. So it sounds like this idea of orchestration is really getting some traction. So help me understand a bit further what really it means. Does it mean that everybody's dancing together and that's a level synchronized? Is that an outcome, or are there other outcomes as well?
Yeah. So let's start with the goal. So the end goal of factory orchestration is waste less time, therefore allowing manufacturers to produce more parts and make fewer mistakes, therefore scrapping less parts. So that is the goal. It sounds simple, right? Who doesn't want to do those two things? Harder to do in practice. The concept of factory orchestration actually originated over 30 years ago. You might be familiar, and some of your listeners might be familiar with the ISA 95 stack, that was defined in 1995. And it's really a great system that outlines how manufacturing components or the layers of a manufacturing plant talk to each other, right? So this starts with, at the top, ERP, and then MES systems, and then you have your kind of SCADA layer in the middle. You've got your PLC and sensors below that, and you got your machines at the very bottom. So basically, how do you get from logical data right down to physical production? And it was a great system. And in fact, you've got a lot of really advanced tools in each one of those layers today, right? You could probably name, and I could name, a lot of great ERP systems that serve the purpose well, and a lot of great MES systems that also serve that purpose well. And machines have come a long way, and so have the PLCs and sensors that control them. The problem is that middle layer, right? That's, and it's defined in different ways depending on what type of manufacturing you're involved in, but it's typically most commonly referred to as that SCADA layer. And it's the layer that connects the logical information on what should be produced with what actually gets produced. And the way that has evolved is sort of a tale of two cities. You've got the large, fully automated manufacturers. And the best example I like to use there is your Coca-Cola bottling plant, right? Where You've got
Yeah.
fully automated systems. There's very little human involvement in this manufacturing. And there's effectively, and I'm oversimplifying here, but there's effectively a knob that you turn where you say, okay, I want to run faster, or I want to run slower. And you know that, as you turn that knob and run faster, you're going to have more defects. As you run slower, you're going to have fewer defects. But you're sort of always trading off between, rate and errors. And that's great when you have fully automated systems where you could just, and there's obviously many more knobs than that in reality, and many more variables and factors that you're controlling. But the essence of it is the same, where you're controlling an automated process, and so that stack works really well together. And it's highly automated. Now the problem is when you have a factory with human workers, and in the manufacturing industry in the United States, if you look at the history of what we make in this country, it tends to be high value, complex components. Many years ago, when the offshoring boom happened, a lot of the low value components, think commodity nuts and bolts and
they went abroad.
Small sheet metal parts, they went away. And the stuff that stayed in this country tends to be high value, high complexity parts or critical components that the OEMs want to keep close because there's a lot of design revisions and that type of stuff. Those types of processes generally do not lend themselves to fully automated production. Now, there's a lot of advancements happening in fully automated production, and I believe that's going to continue to happen. But in general, our manufacturing industry in this country, 300,000 some odd manufacturers, are mostly labor-oriented processes, right? And the problem with a labor-oriented process is your frontline workers don't have a knob on the back of their head that you can turn for speed and rate, to trade that off versus production quality. And humans make mistakes. It's just inherent. You make mistakes, I make mistakes, we all make mistakes. And it's impossible to have 100% accuracy. And so if you think about what factory orchestration does, in essence, is we're filling in that middle layer, connecting what ERP and MES are determining to happen with what is actually happening on the shop floor, and putting guardrails around human-oriented processes. So that example I gave you where an operator pulled up the wrong work instruction. In Harmoni, that doesn't happen because which work instruction is being followed is dictated by the system, because we are the same system that punched that employee in on the job into the ERP system.
So we're talking about then, so I have a fair amount of lean experience. Are we talking about a poke-yoke?
No. So let me give you the simplest way to explain what we do. So there's 3 pillars that make up factory orchestration. So number 1 is labor automations. So we automate non-productive labor. So that's the simplest example is the example I gave you of punching in and out of a time clock system, like an ADP system, or punching in out of an ERP system. So those are 2 simple examples of labor automations. With Harmoni in your shop, you go straight to your machine, straight to your work center, and that the Harmoni terminal is installed at every work center in your factory. It'll immediately identify you. So you'll walk up, it'll say, "Good morning, Mike. Do you want to punch it for the day?" You tap yes. That transaction just happened in ADP, right? Even though it went through the Harmoni system, we're orchestrating, right? Then it'll say, "I see you're working on job XYZ," because that job has an RFID traveler. We use RFID to identify people and jobs and things you're working on. So it'll say, "I see you're working on job XYZ. Do you want to start op 10 on this machine?" You'll tap yes. So now it'll punch you into your ERP system, start your activity in your ERP. Typically, just that exercise alone, having those 2 things happen right at your machine, generally saves 5 to 10 minutes. We've seen it as high as 15 minutes, for manufacturers, just from that employee not having to walk around the factory and do those transactions at different systems. We have a whole bunch of other labor automations, think ticketing systems, where if you need maintenance help, you could submit a ticket through the Harmoni system, or if you need to locate things on your shop floor, you can put RFID tags on literally anything, fixtures, tools, gauges, and find where they are at any given moment through your Harmoni terminal. You could say, "Where's gauge XYZ?" It'll say it's over at machine ABC. So that's labor automation, right? 1/3 of what Harmoni does. The second third of what we do is process control. So because we have that context of who you are, what you're working on, what machine you're at, we can now pull the correct engineering data for that process to prevent those mistakes from happening. And so the engineers, we have a whole engineering change management system in the back end where you can upload engineering data. So for example, work instructions, and you could tie it to a part number. And so if you think about it, right, imagine you have existing work instructions, you upload it, you tie to a part number and a rev in your ERP system. So now when an operator is punched onto a job to make that part and that rev, they're going to get the correct instruction for that part. We're going to communicate any changes, right? So change communication is a huge source of error in factories. And with Harmoni, let's say something changed last week. You might not be following that instruction every time you're making that part. But with Harmoni, it could pop up a message saying, hey, Mike, pay attention to step 18. The bore diameter changed from X to Y. Confirm I understand. Yes, I understand. So communicating that information at the most critical time when you're about to start that operation. So that's an example of our process control. Or a program will deliver the correct program right there to our terminal, and then we'll load it right on that machine. And if they make changes on the machine, we'll detect those changes. So we have the ability to actually detect if operators modify programs, and they can enter notes saying, hey, the tool was chattering, so I had to change the G code at this line. And it will actually show the engineers. They'll send a request right back to the engineer after they change it saying, hey, Mike changed line X to Y, and his note was the tool was chattering. And therefore you as the engineer can evaluate it and decide, well, should I accept that change? Is that an improvement to the program? Or maybe they shouldn't be doing that because now the part is going to heat up the middle is going to get too hot. It's going to mess up the step.
Or they were solving the wrong problem at that time.
They're solving the wrong problem, or there's a better way to do it. Exactly. So keeps control with engineers. That's an example of a program. We do the same thing with check sheets for in-process inspection, all rev controlled. And so the third tier of what we do is observability. And observability has two key concepts. And so people who come from the lean world will appreciate some of the concepts on our observability suite. But basically, we give visual factory indicators right on your shop floor. So imagine walking down your aisle and you see the Harmoni terminals at every work center, and you've got a light, a very vivid indicator light on the top of that Harmoni terminal that is showing you the real-time OEE of that work center. It's not showing you is the spindle running or not, right? Or the machine operating. That's kind of marginally helpful information. In fact, most machines can show you that on their own. What we're showing is, are you making rate, which is a very difficult thing to just see when you're walking by, right? You'll see a person working at without a Harmoni terminal, you see a person working at a machine making parts. They look busy. There's a bin full of completed parts. You don't know how many were made on this shift or last shift or yesterday, but they're making parts. And so with Harmoni, we're going to show, are you making rate? Are we making rate right now? And if the answer is no, pardon me, sir?
Yeah. So if it's no, you can take some action. So the three pillars were labor automation, process control, and observability.
That's exactly right. Yeah. And observability is focused on visual factory indicators and dashboards from the cloud where you can see all of that data centrally and really understand what's happening in your shop. And we're going to give you the root cause of the actual problems because we have all the context.
You know what I really appreciate about those three things? So, and tell me if I think about this, they make me think about some principles of lean that I like to talk about. One is a passion for waste elimination. You talked about, not sitting in line waiting on things to happen, that kind of thing. So eliminating waste, it clearly is part of this process, it seems like. Second part is what I call a passion for respect for standards. So by that, I mean putting in place a way that you have the standards as part of the process control, and they're understood and they're followed, and you make it, it doesn't mean you can't adjust the standard, but you get the standard and you get a chance to question and approve a change. So there's healthy respect for standards. And the third is this idea of visual management, right? Where things are made visible. So those are all three things that are really, in my mind, are foundational for a lean factory. If I understand correctly what those three pillars, that's where my mind goes when I hear you talk about that. Am I off base, or is that?
No, you're 100% correct. And all of these principles, the guiding principles of Harmoni, come from lean principles. But the idea is that we're putting it all in a single out-of-the-box product that ties in with all of your existing systems, with all of your existing machines. We are not replacing ERP. We are not replacing MES. We are integrating with them. We're not replacing your time charging system. We're integrating with it. We're not replacing your quality management system. We're integrating it. What we're doing is we're making the myriad of very effective systems do their job without creating inefficiencies and problems on the shop floor. because what you need to do for the frontline operators is simplify their life as much as possible so that things are automated. So they're spending more time making widgets and not walking around the factory. And that when they're doing that, they're not making mistakes. And so we're putting those guardrails on the process. In fact, it's effectively SCADA for human-oriented processes. And it's, it's a completely different way of approaching it, right? I mean, I wouldn't have, my first inclination when I was experiencing all these problems in my own factories was not, let's go build a company. It was, let's just go buy some software, buy some software and fix it and let's move on, right? I mean, that was my initial reaction. But it was when I realized, wait, this doesn't exist. And how does this not exist? How is there not a product that actually, automates all this non-productive stuff and ties in all these disparate systems into one simple interface?
Yeah. So the question then that I would ask is, if I'm a manufacturer, part of me thinks I'm adding another layer of software into my software menagerie,
Yeah.
So if I want to do this in a way that's not going to add complexity but improve what I'm doing, how do I start? Where do I start? Where do I get the biggest bang for the buck going forward?
So that is exactly what Harmoni is made to solve, is that problem of all these systems. And I could see the kind of the flip side of it saying, well, you are technically another system, and we are. But the whole point of this system is to integrate with all of the others. So what you're doing is, if you think about your shop floor operator's day, where they're working between 5, 6, 7, sometimes different, just depending on the complexity of your manufacturing process, right? It'll be time charging systems, ERP systems, maintenance systems, quality systems, program loading systems, or work instructions. There's all these different systems, and manufacturers have usually have anywhere from 2 or 3 on the low end to 6 or 7 of those on the high end. When after
Right.
Harmoni goes in, your operator interfaces with only one system, period. And they're up and running immediately, right? The implementation time for a typical Harmoni customer is 2 weeks. And it sounds like a system that touches so many areas of a factory, right? And so your first reaction to that is probably, well, how could you put a system like this in place in a factory in 2 weeks? So we spent years building this and engineering this to go in very easy, to install very easy, out of the box integrations with all these different types of systems. And we integrate with dozens of ERP systems. We're adding new ones every month. And so it's over the years, we're building more and more and more integrations with different systems. But whenever we find a system that we don't talk to, our immediate reaction is, that's awesome. We would love to now add that to our tool chest of integrations. So we will build that. And so the general idea is that with Harmoni, it is the only interface for your shop floor operators. And in fact, we have customers who will migrate ERP systems or migrate quality systems while they have Harmoni in place. It's completely seamless to the shop floor. Actually, the shop floor doesn't even know that you've moved ERP systems because their day doesn't change at all. What they're doing is they are interfacing with Harmoni. Harmoni is a highly streamlined, simplified interface. Think, we've taken cues from the Apple ecosystem as to, how you navigate things and do things through the Harmoni device. So it's very simple, touch, tap, showing you just what you need and having it all right there at the work center. And so, you talk about like, how does a manufacturer get their head around putting in place, another layer like this? And so the shortest ROI path when they install Harmoni is always the automations, the labor automations, but it's always the time charging specifically within labor automation. And generally that one automation alone will typically pay for the entire Harmoni system. On the low end, 2 to 3 times over. On the higher end, 4 to 5 times over. Customers, everyone has different shop rates and size factories. But the idea is that when you add up that, 5 to 10 to 15 minutes every time those operators, in the beginning of the day when they have to punch in, then at the end of the day, then before lunch, then after lunch, then before break, then after break, on average, we're adding 30 to 45 minutes of productive time per operator per shift. And when you think about an 8-hour shift, I mean, that's a really meaningful number. And when you throw your labor and overhead rate on top of that, it's a pretty big number. And so that's always the lowest hanging fruit. And they're up and running with that feature on day one, right? There is no,
Makes sense. All that makes sense. So you've explained kind of where we've come from and where we are.
Mhm.
Let me ask you now. I find every other conversation I have is with someone talking about how to use AI, for example, and how it can fit into this thing. And so when you think about the future, I know it's not just AI, it could be digital twins and other systems, but when you think about the future down the road, what evolutions do you imagine for a factory automation or for an orchestration platform?
Yeah. So good question. So over the next 5 years, there's two things I see happening. Number one is factory orchestration as a category grows significantly because this is not a nice to have product anymore. There was a time when efficiencies were nice to have, but when you look at what's going on in this country with the reshoring of manufacturing and the massive surges of domestic initiatives, everything from defense budgets to data center build outs, to aerospace backlogs. There's a huge amount of demand in this country. And then at the same time, you've got fully autonomous factories, that Hadrians, the Machinas, the AMCAs of the world coming out, and effectively coming up with highly automated ways to make parts, where if you are a traditional manufacturer with a skilled workforce, you need to find ways to utilize that skilled workforce effectively. I mean, Harmoni is basically that. Factory orchestration in general as a category is working with those skilled workers to allow them to perform their skilled task more efficiently and continue to make those parts that you're making and ensure that those parts don't end up going to a fully automated factory that's going to be able to beat you on cycle times or whatever other reason they might have. And so just growing factory orchestration as a category is the biggest thing I see over the next 5 years, because we've been growing extremely quickly, but there, like I said, hundreds of thousands of manufacturers in this country. There's a lot of room to grow, and so I see that accelerating significantly, driven by these autonomous factories popping up. But then secondly, we do use AI, and we are using AI in very unique and novel ways. And so everything from typical kind of cloud side AI, where because Harmoni has access to every one of these systems, imagine having agents. We call it HAL, the Harmoni AI Lieutenant, our virtual shop floor manager. And so imagine being able to ask your virtual shop floor manager, what's going on in my shop today, and you're not going to get a biased view, because you want to protect Jimmy, who didn't show up again today, and you're going to get the real rundown on exactly what is happening right now with data from your machines, your ERP system, your quality systems, your maintenance systems. All these different systems that are being orchestrated are feeding in to give you that information. But then we're also delivering edge AI right there at the machines, so assisting operators with all the context of what they're working on. And that is a really important concept, having that context, because we sit in the middle of all these transactions. We're able to deliver really interesting AI applications at the edge.
Yeah, very interesting. Well, it's a lot to think about. That it's really, I guess I continue to be amazed. I don't know if others are as well, but I sometimes chuckle about when I first started in a factory, we had one computer for the entire factory, right? And we ran our equipment on Silamog, on pneumatic controls. Okay.
Right.
And so you fast forward now 4 decades, and you know where we are now, and it's amazing. And the speed of change is dramatic. And so as the systems mature, and the cost has come down, and anyway, it's just amazing what you can do, the technology, how it's advanced and how it's helped us really improve. As we get ready to wrap up our conversation, it's been great to kind of hear your thoughts on factory orchestration, and where it's going. Do you have any final thoughts for our audience as we get to the close of this time together?
So I think what I'll say is we're in an amazing time right now. There is a reindustrialization happening in this country of massive proportions. I talked about some of the drivers a little bit earlier, right? You've got $1.5 trillion defense budgets. You got $1.5 trillion aerospace backlogs with Boeing and Airbus. You got trillion plus data center buildouts happening next all of that next year alone, and all the same time when you've got a labor shortage where for every 3 retiring workers you only have 2 coming into the workforce, right? So they're projecting 1.9 million jobs, manufacturing jobs shortfall over the next decade. And when you think about that in the context of, roughly 13 million workers in the manufacturing industry, that's a lot. But then at the same time, if you were to boil that down to say, well, that's 1.9 million jobs that we need over the next 10 years, that's about 190,000 jobs a year. And if you were to equate that 190,000 jobs to the 13 million workforce, I've done that math, and it works out to 6 minutes per shift. If we could get 6 minutes per shift more efficient with today's workforce, we have effectively met the labor shortage. And if we could get 6 minutes more effective next year, we'll meet next year's shortage as well. And Harmoni is adding 30 to 45 minutes of productive time out of the box today on day one per operator per shift. So I see what we're doing as having a greater cause. That this isn't, to me, about just rolling out a product and getting, commercial success. Yes, that's nice. But what we're really trying to do is rebuild manufacturing strength in this country. We're focused on the skilled workforce that we have in this country that's making all these amazing parts that we make, everything from landing gear, pistons to complex defense components. And we want to help meet that need and step up to the plate and facilitate this reindustrialization.
No, that's great. Well, thanks for that perspective. So really appreciate you taking time out of your busy schedule to talk to us about factory orchestration, kind of what it is and your perspective on where it's going and what it can do for us. So thank you for that.
Thank you for having me.
So the Industry 4.0 Club, we'd like to know what you're doing to advance the deployment of Industry 4.0. Reading an article, I hope, or maybe attending a workshop, or even developing a strategy, much like David talked about, for how to advance, your factory with something like Factory Orchestration and other tools. So we'd love to hear from you, to know what you're doing and how you're helping to move your factory forward. Drop us a line at our website at www.industry40club.com or on our LinkedIn page. We also host conversations like this weekly. So if you'd like to be a guest and join us and you have something you'd like to share as a thought leader, drop us a note and we'll get you on our broadcast hopefully very soon. With that, again, David, thank you for your time today, and look forward to seeing how factory orchestration evolves.
Thanks very much, Mike.
Bye-bye. Have a great day.